Hello friends, in class 12th chemistry unit 4 chemical kinetics, in the previous video we have discussed about the rate of reaction. Now in this video we are going to discuss about the factors affecting rate of reaction, rate law, rate constant and meaning of order and molecularity of reaction. Now let us see one by one. First of all, what are the factors which influence the rate of a reaction? Rate of reaction depends upon the experimental conditions such as concentration of reactants, pressure in case of gases, temperature and catalyst. First see dependence of rate on concentration. Rate of reaction decreases with the passage of time as the concentration of reactants decreases. In the previous video, we have discussed as the reaction proceeds, concentration of reactant is decreases. That's why rate of reaction is also decreases if this expressed in terms of concentration of reactants. Conversely, we can say rates generally increase when reactant concentrations increase. Clear? So rate of reaction depends upon the concentration of reactants. Rate expression or rate law. The representation of a rate of reaction in terms of concentration of the reactants is known as a rate law. It is also called as a rate equation or rate expression. Here three things: rate law, rate equation, rate expression is the same, and this represent the rate of reaction in terms of concentration of the reactants. Consider one general reaction. A plus B convert into C plus D, where these capital letters represent the chemical species and small letter represent the stoichiometry coefficients of the reactants and products. That's why we can say rate expression or rate law for this reaction is rate is directly proportional to concentration of A power X, concentration of B power Y, and both terms, that is A and B, are in multiplication, where exponents X and Y may or may not be equal to the stoichiometry coefficients A and B of the reactants. Above reaction can also be written as rate is equal to K. We remove the proportionality constant and this K has written A power X, B power Y. And this, as we know, rate is the change in concentration of reactant per unit time. Okay, that's why this expression is known as differential rate equation. Okay, and where this K is known as rate constant. Then we can say rate law is the expression in which a reaction rate is given in terms of molar concentration of reactants with each term raised to some power, which may or may not be same as the stoichiometry coefficient of the reacting species in balanced chemical equation. This is the meaning of rate law. Now consider one example. 2NO plus O2 gives 2NO2. 4 experiments are shown in this table, 1, 2, 3 and 4. And in this column, this initial concentration of NO is given in mole per liter. In this column, initial concentration of O2 is given in mole per liter. And this column represents the initial rate of formation of NO2 in mole per liter per second. Okay, now just see some conditions. When the concentration of NO is doubled and O2 is kept constant. Clear? NO is double. Now see experiment number 1 and 2. If we go from this to this is 0.36 to 0.60. This is double. But concentration of O2 is constant. Okay. Now see the change in the initial rate of formation of NO2. This is from 0.096 to 0.384. Now if we compare, this becomes 4 times. Clear? What it indicates that rate depends upon the square of the concentration of NO. If concentration of NO is doubled, rate becomes 4 times. It means rate depends on the square of the concentration of NO. Okay. Now see, when concentration of NO is kept constant and concentration of O2 is doubled. Now just see in this table, experiment number first and third. This is concentration of NO is constant, and see in this case concentration of O2, and this in third, this is doubled. Now see the change in rate of reaction. This is 0.096 and this becomes 0.192. Now what is the change? Now this is twice. This is twice. It means as the concentration of O2 is doubled, rate of formation of NO2 is also doubled. Okay, what it indicates? This indicates that rate depends on concentration of O2 to the first power. Okay, this can be expressed in terms of rate equation. That is, rate is equal to K NO2 power 2, and this is O2. And this differential form can be written like this: minus dr by dt is equal to K NO power 2 O2. Is it clear? Now some more examples to explain this rate expression. Like see CHCl3, Cl2, these are the reactants, and if we write the experimental rate expression for this, rate is equal to K. This is concentration of CHCl3 power 1, but concentration of Cl2 becomes half. It is not equal to stoichiometry coefficient. Okay, in the same case, this is the hydrolysis of ester. This is ester when react with the water. Okay, if we write the rate expression for this, rate is equal to K. This is the concentration of ester power 1, and this is concentration of H2O power 0. It means rate of reaction is independent on the change in concentration of H2. Okay, what it indicates? That is, rate law for any reaction cannot be predicted by merely looking at the balanced chemical equation. That is, theoretically we can write the theoretically rate expression or rate law. It must be determined experimentally. Clear? Now see next, order of reaction. Now just see rate equation for this one equation which already discussed, hypothetical equation. Rate is equal to K A power X B power Y, and where this sum X plus Y, okay, it gives the overall order of a reaction where X and Y represent the order with respect to reactant A and B respectively. Okay, then how can we define the order of reaction? We can say sum of powers of the concentration of the reactants in the rate law expression is called the order of that chemical reaction. Order of reaction can be 0, it may be 1, 2, 3, and even a fraction. A zero order reaction means that the rate of reaction is independent of the concentration of reactants. Okay, the reaction taking place in one step are called elementary reactions. But there are some reactions which are not taking place in a single step or in a one step. They taking place in more than one step. Then when a sequence of elementary reactions, that sequence if you describe, that is called the mechanism. Sequence of elementary reaction gives us the products. The reactions are called complex reaction. Is it clear? Now what are the units of rate constant? Now again see the one general reaction. For this we can write rate is equal to K A power X B power Y, where X plus Y that is equal to N, and this is called order of the reaction. And from this expression we can write K like this. K is equal to rate divided by concentration of A power X, concentration of B power Y. Now what is this rate? Rate is the concentration divided by time. This is multiplied by 1 divided by concentration power N. Why this is? Because A is also the concentration term, B is also the concentration term, and sum of X and Y that is equal to N. That's why we can write concentration power N. And when this concentration power N go in the numerator, then we will get this term. Concentration 1 minus N divided by time. It means unit of the rate constant depends on the value of N. And what stands N? N is the order of a reaction. Okay, now see this table. For zero order reaction, that is n is equal to 0. And if we put this 0 in this formula, 1 minus 0, that is 1, only 1. And if concentration is expressed in mole per liter and time in second, then we can say this is mole per liter per second. This is the unit of a rate constant for zero order reaction. Again, see this unit we also discussed. Have you remember? This is the unit for rate of a reaction. So we can say for zero order reaction, unit of a rate constant is the same as the unit of a rate of a reaction. Okay. Now come for first order reaction, that is when n is equal to 1, when we can say concentration power 1 minus 1, this becomes 0, and then this whole terms become 1. 1 by time. It means time inverse. If time is measured in the second, then we can say the unit of a rate constant for the first order reaction is second inverse. Now for second order reaction, when this n is equal to 2, that is concentration 1 minus 2 divided by time. This is 1 minus 2 means minus 1. Concentration minus 1. This light, if concentration in mole per liter, then we can say mole minus 1 liter second inverse, or we can also write like this, liter mole inverse second inverse. Is it clear? It means if unit of the rate constant is given, you must be able to find out the order of that reaction. Okay. Now next one is the molecularity of a reaction. The number of reacting species. Reacting species may be atoms, ions or molecules taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. Clear? Unimolecular reaction. If only one reacting species is involved in collision, then this is called unimolecular reaction. Then this is the decomposition of ammonium nitrate. That is ammonium nitrite. NH4NO2 gives N2 plus 2H2O. Bimolecular reaction. Simultaneous collision between two species is taking place. Then this is called bimolecular reaction. For example, dissociation of hydrogen iodide. 2Hi gives H2 plus I2. Trimolecular or termolecular reaction. It involves the simultaneous collision between three reacting species. For example, 2NO plus O2. 2NO plus O2 gives 2NO2. Two molecules of NO, one molecule of O2. That's why this is trimolecular or termolecular. The probability that more than three molecules can collide and react simultaneously is very small. Clear? That is, collision between more than three molecules is rare. Hence, the reactions with the molecularity more than 3 are very rare and slow to proceed. It is therefore evident that complex reactions involving more than 3 molecules in the stoichiometric equation must take place in more than one step. Clear? And when reactions taking place in more than one step, then the slowest step in a reaction that controls the overall rate of reaction is called the rate determining step. Slowest step controls the rate of reaction. That's why this is called rate determining step. This can be compared in case of, if we say, relay race. How much time race will be completed? This is decided by the person who runs slow. Is it clear? That's why slowest step decide the rate of reaction. That's why that is called rate determining step. Now just see, there is the one example is there. Decomposition of hydrogen peroxide, which is catalyzed by iodide ion in alkaline medium. This is H2O2, I minus in alkaline medium. This give H2O plus O2. For this, the rate expression can be written is, this is the differential form of rate of reaction, and this is equal to K H2O2 power 1 and I minus. Again remember, I minus is not involved in the reactant. Clear? But this appears in the rate expression. Okay, it means this is a complex reaction and it taking place in the two steps. In the first step, H2O2 react with the I minus, form H2O plus IO minus, and this is a slow step. That's why this is rate determining step. And in the second step, H2O2 react with IO minus, forming H2O, I minus and O2, and this is the fast step. Again see, I minus here, this is reacting, but in this case this is again appearing. That's why this is not appear in the overall reaction in the reactant side or in the product side. That's why this is a catalyst. Now in this case, this IO minus is called as an intermediate because it formed during the course of reaction but not in the overall balanced equation. Is it clear? Now in this reaction we can say this first step is a slow step, and that's why this is a rate determining step, and it involves the concentration of H2O2 and I minus. That's why we are having this is the rate expression for this reaction. Is it clear? Now, after discussing this, you must be able to differentiate order of reaction and molecularity of reaction. Now, just see order of reaction. This is the sum of powers of the concentration of reactants in the rate law expression. This is called order of reaction. In this case, number of reacting species taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. This is experimental property, this is theoretical property. It may be any number, fractional, integral or even zero, but it is integer excepting zero. It means molecularity of reaction cannot be zero and it cannot be in the fraction. Order of reaction may be changed with the change in experimental condition, but it cannot change. Order of reaction is applicable to elementary as well as complex reaction, but molecularity of reaction is applicable only for elementary reactions, and for complex reaction molecularity has no meaning. Is it clear? This is the one of the important topic of this chapter, chemical kinetics. Thank you.